And here's the explanation for the second video, problem number 1 of the week 2 explanations.
So for the second problem, we were given a velocity equation with that x component, and it is kt squared with k being a constant. We are also given two time conditions, one for time at time 0 and one at 1. So the time at 0 is 0, and the time at the second point is 3 seconds. And we are also given two positions. At 0 is -9 meters, and the other one is +9 meters. So given that there is an x component in this, we are going to be able to integrate that initial velocity equation with respect to t, and we'll have x left over on the left, and we will be able to use that to solve for that constant eventually. So once we integrate the velocity function, kt squared, with respect to t, we're going to get k over 3 t cubed plus c. And obviously we're going to get the c because whenever we integrate something, we are going to have a constant left over. So using that first point at time 0, which was 0, one plugs that back into the equation, and similarly using the x at 0, everything cancels out in that velocity equation, and the only thing that's left over is c and the x. So the constant is going to be -9. The constant from the integral, not the constant in the equation. So now once we have the c value, like we did earlier, we can plug in 3 and 9 for t1 and x1, and we're going to get 9 equals k over 3 cubed, and that's just plugging in that 3 value into the t variable. And after a little bit of simplification, we find that the constant is equal to 2.